All right, we'll go through the test review today. Test will be tomorrow then. First question, write 1/6 to the -4th power equals 1296 in logarithmic form. So it'd be log of base 1/6 of 1296 equals -4. Any issues getting from logs to? Okay. Yes. Evaluate log 16 of 1/8. You could do this one of two ways. If you've got a calculator, you could just plug in, change a base. Log of 1/8 divided by log of 16. I personally like, if I just set this equal to x, this is the same thing as saying 16 to the x equals 1/8. And then if we get the same base, 2 to the 4th is 16. And 2 to the -3 is 1/8. Right? Then you could just set 4x equal to -3. X equals -3/4. And you're done. So kind of depends. I mean, if you don't have a graphing calculator or a calculator that can do logs for you, then I like to get just the bases to be the same and then solve. That makes sense? All right. Next one, I have an equation where I'm adding logs of the same base. So to do this, I'm going to multiply these together, and I can drop the logs then. All right, everybody see that? See why I dropped the log? Okay. So x squared plus 2x minus 35 equals 0. X plus 7, x minus 5 is 0. So x is equal to -7 or 5. And when I put in a negative number here, I can never have a log of a negative number. So -7 won't work, but 5 will. So the only answer then that works is 5. That makes sense? Okay. Next one, find the value of log base 5 of 87.2 using the change of base formula. So this is just log of 87.2 divided by log of 5. And then I just put that in the calculator. Log of 87.2 divided by log of 5. And I get 2.77, 2.78. All right, number 5. Solve, and these have different bases. So what I can do is what? Exponentiate both sides? Is that what you guys did? Or did you take the log of both sides? So what I would do then is maybe take log base 4 of 4 to the x minus 3 equals log base 4 of 7. I can't change the base on one side. It has to be the same base on both. I'm going to take the log of both. Now this comes down, and what's log base 4 of 4? Yeah, so I just have x minus 3 here equals log of 7 versus, am I doing that right? Wait, where'd my x go? That's my problem. So there is x times log base 4 of 7. Okay. So if I can, I'm going to get everything with an x on one side and everything without on the other. So I'm going to take x minus x log base 4 of 7 equal to 3 when I add 3 to the other side. Factor an x out. And then just divide. And log base 4 of 7 is just a number that I can do in the calculator. So 3 divided by, put parentheses, 1 minus, parentheses, log 7 divided by log 4. And I'll get negative 7.43 for x. Is it right? I don't know. Maybe I should check it. Hopefully I have the review key in here. Oh, it's right here. Okay. What number? Yes, I got it right. Negative 7.43. Okay. I hate to do all that work and then wonder if I'm teaching it right. So, questions on that process? You could have taken the log of base 7 of both sides. One hint that I do, take the base of the number that's got the more complicated exponent. That'll save you time in the end. Okay. Okay. Evaluate log base 5 of 156. Again, that's just change of base. So log of 156 divided by log of 5, which is 3.138. All right, solve e to the 4x equals 98.6. So what do we do when we have e as a base? What can we do to both sides to help with that? Take the natural log. Yep. So ln e to the 4x equals ln 98.6. Ln e to the 4x is just 4x. So x is equal to natural log of 98.6 divided by 4, 1.15. All right. Next one is a condense. So they both have the same base, base 10. First thing I'm going to do is move this up to the top. So I'll have log of x squared minus log of 3. So this is going to be log of x squared over 3, because it's subtraction, and that's condensed then. To expand, I'll have log of base 9 of 13x squared minus log base 9 of y to the 5th. This can be broken up into 13 times x squared. So this is log base 9. It's hard to write a g and a 9 right after each other. Of 13 plus log base 9 of x squared minus log base 9 of y to the 5th. And now I can bring, actually, log base 9, yes. Yeah, that'll work. Log base 9. So the 2 comes to the front, the 5 comes to the front. My final answer then, two log base 9 of x minus 5 log base 9 of y. This one's the one most people forget about, because you see that as one term instead of a product of 2 terms. So you forget to break that up. All right. Evaluate ln e to the 22 minus 3 ln e cubed. Well, ln e to the 22 is just 22. And, well, yeah, and then ln e to the third power times 3 is just 9. So that should be, what, 13? Okay, next one, we're going to go ahead and condense the left side to be 2x times x minus 2, set that equal to 1. And now I can just use the 6 to the first power equals this, which is 2x squared minus 4x. And now it's a quadratic. Minus 6 equals 0. Factor the 2 out. And this is going to be minus 3 positive 1. So x will either be 3 or negative 1. It can't be negative 1, because it'll make these both negative. So 3 is the only possible answer. Don't forget to check them at the end. Questions on that one? Starting to come back to you a bit. All right. We'll do the bonus while we're here. So a to the 12th to the 4th, the square root, is a to the 12 over 2 raised to the 1/4. Equals x. So this becomes what? 12 over 8, which is 3/4. And it says to write it as a logarithm. So this is a to the x, no, log base a of x equals 3/4. Let's try 3/2. 12/8. It's a little better. Okay, I feel better now. Okay, this one they just give us an exponential equation. A skydiver jumps from a reasonable height above the ground. The air resistance she experiences is proportional to her velocity. The constant of proportionality is 0.4. It can be shown that the downward velocity of the skydiver at time t is given by this equation, where t is measured in seconds, v of t is measured in feet per second. So that's velocity. So the first question, find the initial velocity of the skydiver. So that would be t equals 0. So I'm going to plug in 0 for t. E to the 0 is 1. 1 minus 1 is 0 times 80 is 0. So the initial speed is 0. The velocity after 5 seconds, I just put in 5 for t and then plug it in the calculator. The velocity after 9 seconds, again, same thing. The maximum velocity of a falling object with wind resistance is called its terminal velocity. From the graph of v of t, find the terminal velocity of this skydiver. Okay, so we're going to go ahead and just plug this equation into y equals, so we have 80 times 1 minus e to the negative 0.4 times the variable, parentheses, and graph. And when I graph it, I am going to need to, I'm trying to figure out what to make my window. Let's make the x. Wish I could probably do this on Desmos, just so that people watching the video might see what I'm looking at instead of just me. I'll do that. 1 minus e to the negative 0.4x. Okay, now I'm going to need to zoom out. And it looks like my terminal velocity is at 80. You good?
Yep.
Okay. Thank you. Okay. So that was part D. All right. How do we sketch the graph of this? What's it going to basically look like? Where do I put my stylus? Well, one way to do it, to think about it, is when x is 0, where does it go through? 1, because 3 to the 0 is 1. When x is 1, what's y? 1/3, right? The negative flips. When it's 1, it's 1/3. A little more. 2 then is 1/9, 3, and so on. So let's do -1. When x is -1, it's 3 to the 1, which is 3, right? So we can kind of see it's going to have some kind of shape like that. So what happened with when the x became negative, it flipped over the y-axis. Because normally e to the x has that kind of general shape. So just because the x was negative, it flipped. If the 3 had been negative, it would have flipped over the x-axis. Remember some of those rules? Okay. So 1/4 of e to the x, same kind of deal. When x is 0, it's 1. When x is 1, e to the x. E to the 1 times 1/4. E divided by 4 is 0.68. This is going to be less. Is that right? And then anything e to e squared. Let's just try that. E squared divided by 4 is a little bigger. Does that make sense? No. I've done something wrong. When x is 0, y is 1/4, which is 0.25. When x is, so it's getting a little bigger as it goes. I'm going to go to, when x is 4 or 2, I got 1.7. When x is 4, e to the 4th divided by 4 is just e, so it's 2.7. So it's just going to gradually start getting bigger. It's going to slope less steep because of the 1/4. Right? If it was greater than 1, it would be steeper than e to the x, but since it's less than 1, it's going to be 1/4 of the time, a 1/4 as steep as e to the x. Okay. Suppose 1,750 is put into an account that pays an annual rate of 4.25 compounded weekly. How much is in the account after 36 months? So you need to know A is A sub 0 times 1 plus the rate over n raised to the nt, where n is how many times it compounds in a year. So 1,750 is A sub 0. 1 plus the rate is 0.0425 over weekly, so that's 52, raised to 52, and it's 36 months, which is 3 years. So you want to make it 52 times 3, because it's always in terms of years. Okay, so I take 1 plus 0.0425 divided by 52. I raise that to 52 times 3, multiply that by 1,750. I get 1987 and 87 cents. Hey, that's right. I remembered my equation and everything. So proud. Okay, last one. Use the graph of y equals 3 to the x to describe the transformation. So you don't need to graph this one. I just wanted a description. The description would be it flips over the y-axis, or the y-axis, because this is the x-axis, yes. I was thinking x and I kept saying y. And it shifts to the right 2 units. And the 2 is going to make it a steeper increase as it goes than just the original. Right? So it flips over, it's a little steeper by factor of 2, and then the whole thing shifts over to the right 2 units. That's how I would describe that. Make sense? And I think we are done. Anything that you're struggling with? Condensing, expanding, getting back and forth from log to exponent? Always try and get your bases to be the same and just set your exponents equal when it works. It's a lot easier than the other way. Okay? All right. Tomorrow we'll do the Chapter 7 test.